Hello, my name is Jeppe. I'm going to tell you a little bit about how we set up CI/CD on Azure platform. So in the beginning, we had to make a new tenant because we didn't have appropriate privileges to publish a web app on the VIA tenant. So you go in here, Azure portal, create tenant. So we created our own. This is our own tenant. And now we made an organization on the DevOps platform. So now we want to tie that organization to the new tenant we made. So we go here into Active Directory, and we can set it up here. It's already set up, otherwise you can do it there. And then we go to the project that we made inside our organization. There's a planning tool here for the work items, backlog, everything. And then there's a repository we made. We cloned it from GitHub, but you can make a standalone one. And then we look at the branches that we have here. We have a master branch that we want to be protected. So we set up branch policies here. Here we can see that we need reviewers, and we have a JUnit test that we built before you can merge into the master branch. So we set up pipelines here for testing, which is on pull request into master. And we have a deployment which is tied to a merge in the master. So we can see a little bit about what's inside the pipeline. We specified it using the YAML script interface. So we can see here that there is no trigger here. Usually when you have a YAML pipeline, whenever there's a branch in the repos, then it will trigger any pipeline. But here we override. So this is only triggered when you make a pull request into the master. So here's all the tasks that you specify. Some variables, have some variables for overview. And then you install Node on the environment. You make the environment here in the cloud. And then you simply test it here, test, and you specify that in the launch script for the node to read. And then we publish the results here from the test. If this fails in any way, especially this one, if any test fails, then it will not be able to merge. So this is our React app that we have published online on Azure. And you can see here that everything is working, all the process is returned. So now I'm going to change it to check the pipelines. Here we have a headline, and I'll change that headline. So here I change the headline, and I'm going to push it now to portal. So git push. So I created the pull request into the master, and I can see here that the JUnit tests, they are currently ongoing. I'll just approve it, and then I can look at the code here. We see now that the tests returned positively, so we're ready to merge. So I go for merge, and I merge. We see here in the overview that the test pipeline finished 5.5 minutes ago, and currently we are deploying after the merge by CI from master. The pipeline for deployment, we see it's triggered by update on master, and we see that it publishes to Azure. We see that the deployment pipeline is now finished successfully, and we can see also here that the headline has changed. The changes has been deployed to Azure.
Hello, this is Ernesto talking. The beginning of the data process started by importing data to the Python using pandas library. After the data was imported, we were using the small function which was checking the data if it has some null values, and if it does, we will replace them or just drop the entire row. It depended on the tables. So for example, some of the flights table we just dropped because we have plenty of rows and some of the data wasn't that important. But some of the values, such as planes, there was too many values to be dropped, so we just like filled them with a 0. After the cleaning of the data was done, we started making by creating the SQL tables. It's just simple tables based on the the data that was provided for us. So just some of them just have a just primary keys, simple things. Uh, with some of them we had some issues. The main thing it would be that when we are creating, when we're pushing the data to the SQL server, we were having some problems by adding the constraints between the planes table and the flights table, because there's too many values that doesn't exist in the planes table as it is exist in the flights table, such as the primary key. So to avoid this mistake, we were just like didn't put a foreign key at all between those two tables. After the SQL tables were created, we create a SQL database inside the cloud. We create a database inside the cloud, and you can just log in. You can check that all the data is here. It's like selecting the top 1,000 rows. Most of the data is there. And as an example, we can just take and just check the number of flights each manufacturer with more than 200 planes are responsible for the analysis. We can just run the simple SQL script and just check if it's working, and it gives you how many flights each manufacturer had based on the who has more than 200 flights is.
This is Yasin speaking, and I will show you how our workflow was. So here we have the Azure organization. We have the product backlog. So here we can see all our different tasks. In total, we had 4 sprints with different tasks for each sprint. And if we go here, for example, in the backlog, you can see which person was actually responsible for each of the tasks. We click on analytics here as well. Then you can see a burn down chart. So this was pretty. Hello, this is currently Yasin speaking. Our group consists of me, Jeppe, and Ernestus. What you can see on the screen right now is a sequence diagram showing the system. First, we have our web application that fetches a REST API using Azure functions. The Azure functions return the REST API using HTTP triggers. And then you have the Azure function that creates a connection to the database and requests the specific data using SQL queries. Before we put the data into the database, we made sure that it was pre-processed using Python, and we also use Microsoft SQL Server to create tables. Now I want to show you the code. In this screen you can see how we made the chart for our system. We are using Canvas.js chart, and here we specify the properties of this chart, what type of chart it is, and then we get the data using the API that we just made, the REST API, to put into the chart. Now I also want to show you how we made the Azure function. So in this screen you see the Azure function. This is an HTTP trigger. The first thing we do is we set up a configuration, we establish the connection, and then we execute our query, and then we take the data and we create a JSON object, a REST API. If we look in the console right here, you can see that it is connected, and we have the data here as well, and right now it's running on the local host. So I'll give you a demonstration right now. So this is our project running on the local host right here, where you have all the charts. We also have one running on the deployment link. This is the link for the HTTP trigger that shows all the data here. And if we go to the cloud, if we go to the Azure portal, we can access our functions directly. Here we can add the code. We can also code directly in here as well. There are some interesting features such as integration and test monitoring function keys. And here we can click on get URL, and then we will be able to access the REST API.